how much, and does it say what mass?
15 grams.
I mean, in terms of the question.
Oh, well.
Yeah, it asks what masses, so I need to know how many grams of iron oxide and how many grams of aluminum are required to produce 15 grams of iron. Now I have to do this independently. I have to do one calculation to determine the mass of aluminum required to produce 15 grams of iron. Put that number aside, then set up the second calculation to determine the mass of iron oxide needed to produce the 15 grams of iron. The balanced equation is the key because it relates any two products or reactants. I'm always going to start with the given measurement, or given, you might be given more than one, but this is what I'm given, 15 grams of iron. And if I can't do anything else with that, I'm going to at least manipulate it in some fashion. And what can you do with grams of anything?
Change it to moles.
Convert it to moles. So 1 mole of iron has a mass of what? 55.85. Okay, I'm just going to get cents. Grams of iron. Now what I've done here is multiplied my original measurement by what's called a conversion factor. And if you already know this, or just bear with me, because I'm assuming that some do not. So this 1 mole over 55.9 is what's 59.9 grams, is what's called a conversion factor. It relates two different units that represent the same quantity, because 1 mole of iron is the same quantity as 55.9 grams of iron. All it is expressing that quantity of iron in different units. So mathematically, if I take a number and divide it by something equal to it, what do I get?
Same number.
Same.
Well,
I get
same
1, not the same number, I get 1.
1.
So all I'm doing here is I'm multiplying 15 grams of iron by 1. And mathematically, if I multiply any number times 1, what do I get? Get the same number. So I'm not changing the number. I'm not changing the quantity. All I'm doing is expressing it in different units. And what I'm going to do is multiply by a series of these conversion factors until I get to grams of iron oxide. I'm not going to stop here and do a calculation because each of my conversion factors are going to be equal to 1. And I can multiply by 1 an infinite number of times and never change the quantity. Once I've introduced moles of iron into my conversion, now I can use the balanced equation and relate moles of iron to anything else in this reaction. And I'm going to first answer this question. How many grams of iron oxide are needed to produce this 15 grams of iron? So in my balanced equation, for every 2 moles of iron that are produced, for every 2 moles of iron that are produced, it requires 1 mole of iron oxide to react. An additional note you might want to write to yourself is that units are just like variables. And if I'm multiplying and I have x in the numerator and x in the denominator, what can I do with those x's? Cancel them out. So I had grams of iron here and grams of iron here, so they cancel out. I have moles of iron here, and now I have moles of iron in the denominator, so they cancel out. The only unit remaining is moles of iron oxide. But I need one more conversion factor because I need the mass of iron oxide that produced 15 grams of iron. So my last conversion factor, I'm going to have 1 mole of iron oxide, that's iron 3 oxide. Iron oxide in the denominator, and I need to know now the molar mass of this iron oxide. And what is it?
150.
How much?
158.
158. And again, if you round it a little differently,
159.7.
I got 59.8.
59.8. So it's closer to 160.
60, yeah, let's go 60.
Right. I know, so I haven't asked you to pick up a calculator. I haven't picked up a calculator yet. All I've done is set up my conversion. The only units remaining now are grams of iron oxide, and that's what I'm looking for. That was the first question that I needed to answer. So now, I pick up my calculator, I multiply through the numerator and divide by the product in the denominator, and that's going to give me the grams of iron oxide required to produce 15 grams of iron in this particular reaction. Okay, your answer should be rounded to 3 significant digits because that's what you're basing this on. There are 3 significant digits in the original measurement of 15.0 grams. So what do you get?
21.46 grams.
21.4 or 5? 6 grams of iron 3 oxide. And I will accept a range because, again, I know you're all going around. But if we, when you're pulling average atomic masses to use, carry it out to the 10th place in determining your molar masses, and then we should be fairly precise. We'll come up with our timeline. So, in this reaction, assuming that you have enough aluminum to completely react with this iron oxide, it takes 21.5 grams of iron 3 oxide in order to produce 15 grams of iron. Now, to answer the second question, how many grams of aluminum are required, the setup is going to look very similar. I could actually use this number if I wanted to as my original number, because this measurement now is valid. But to be safe, just in case you made a mistake somewhere in here, but we know we didn't because I guided you through it, we're going to still just use the original 15 grams of iron. Again, grams do nothing for me. I need moles. And the molar mass of iron has not changed from the first conversion to the second. So it's still 55.9 grams of iron per mole. As far as the balanced equation goes now, it takes 2 moles of aluminum to produce 2 moles of iron. So this comes from the balanced equation. And then the mass of aluminum you've got to be careful because oftentimes students will want to write 2 moles of aluminum in this conversion. And you can do that, but you just have to be careful and you would have to double the mass of aluminum. For this, to convert between moles and grams, I would just insert the molar mass of 1 mole of aluminum. And 1 mole of aluminum has a mass of what?
23.96, 26.98, excuse me.
Okay, so for simplicity's sake, I'm going to say 27 grams of aluminum. Now, just to double check, grams of iron cancel out, moles of iron cancel out, and moles of aluminum cancel out. So the only units remaining are grams of aluminum. And when you evaluate that, what do you get?
You get 7.25 grams of aluminum.
7.25 grams of aluminum. Now, we know that to answer that last question, we can actually use one of 3 measurements. We can either use the 15 grams of iron, which was given. We can use the 21.5 grams of iron oxide, which you calculated was required to produce 15 grams of iron. Or you can use the 7.25 grams of aluminum, which is required to produce the 15 grams of iron. All 3 of those are now, assuming that you did these right, are valid and can be used to calculate the mass of aluminum oxide produced. Here's what we'll do. This group use this to calculate. If you've already done it, then you're set. But I want these of you to convert 7.25 grams of aluminum into grams of aluminum oxide. I want the middle group to convert 21.5 grams of iron 3 oxide into the aluminum oxide. And those of you against the windows, you probably already did it. But convert 15 grams of iron to the aluminum oxide.